Hello, builders. Thank you for coming to my talk. I'm Daniel Bennett, a Nomad engineer at HashiCorp. And I'm here to tell you about my MIDI task driver for Nomad that turns Nomad into an actual orchestrator that plays some music software like, in my case, Ableton Live. I'm going to try not to apologize for not being a professional presenter. So sorry in advance if I do apologize for that. At the end of this, there will be a demo. So if you have headphones nearby, go ahead and grab those so you can hear my sick beats. All right. What's this all about? Like you, I assume, I am here to learn. And I love to learn by making silly projects. I've made a deep, dark secrets engine for Vault, distributed Conway's Game of Life on Nomad, where each cell was a Nomad job before I joined the team. And shortly after I joined the team earlier this year, we had a hack week, and this is what I did for that. So what this is all about today is we'll talk about how music is made briefly and how I crammed Nomad into that picture. Talk about task drivers, how they usually work, like high level at least, how mine works differently and worse, but in a convenient way for a hack week and for music coordination. I'll show you my MIDI job specification, how I templated it with Pack. I'll do a quick little demo and walk you through the Ableton setup on the music software side. We'll look at some code, which hopefully y'all are excited for. I'll play a song-length demo right towards the end, and then I'll encourage you to go forth and make your own weird or useful or both task drivers for Nomad. So first up, how is music made, and can Nomad help me with that? Nomad can't really help you make better music, but it's not supposed to. I don't know why you would expect Nomad to be able to do that, so it's kind of on you, really. How music is usually made is you have a DAW, a digital audio workstation like Ableton or Pro Tools or FL Studio or Logic. There's a whole bunch of them. And you push buttons in this piece of software, and you play instruments into it or push more buttons until you're happy with it and music comes out the other side. But in my many years now of dabbling with this here and there, I talked to a lot of musicians about songwriting and music making, and everyone unanimously agrees that it is too easy to make music this way. Making music is too easy. So let's engineer our way out of this problem. We'll keep Ableton in the picture here, of course, but we're only going to use it to produce a MIDI file. It's just a handy editor to be able to produce a MIDI file for us. And this is a file that contains which notes should be pressed at what time and how hard and for how long, stuff like that. We'll do that for each instrument. And then we'll feed that into a Nomad job specification, which is templated by Nomad Pack, which is pretty nice for demo purposes, and just in general. So then that MIDI file, still just a file name, will get fed over to Nomad as a job. Nomad will go, hey, I need a driver for that, and it will use my MIDI driver. MIDI driver will slurp up that MIDI file, process it, and then send the actual MIDI instructions over a MIDI port that's running on my Mac here. Ableton will listen on that port and then produce the music. This is what we really like to see as engineers. Really nice, complicated flow diagrams. It's just the best. Cool. So how do task drivers work? And how does mine not work as good? This is how things are usually set up. You've got a Nomad client agent running on a host machine. It receives some work to do, and if it doesn't have the driver plugin built into it, like Docker is in there, exec is in there, and some others, Then it will launch a driver plugin binary, which gets a process started. And then it'll talk to that process over gRPC and send it some pretty sensible instructions about, Nomad-y things to start and stop tasks and so on. And the driver process speaks over, I put API in quotes here because API usually makes you think of like a REST API, but very much not necessarily so here, although it can be. It might just be a command on the operating system. Hey, please run this command for me. It could be speaking over a Unix socket, maybe to Podman or Docker to run a Docker container. It could be asking QEMU to spin up a VM for us. And then that thing does the heavy lifting, which produces an actual workload over here on the other side, which is the thing that we really care about. This is really nice for at least a couple of reasons. One is that this can have all the real business logic that it's concerned with. It can be rather complicated how it manages all this stuff. But then on the driver side, you can have a pretty thin, almost like a client to a server kind of relationship here. So the driver code may have only enough logic in it, or a little more logic than to read configuration from your job specification and sort of forward that along in a meaningful way to whatever it wants to talk to. Another reason this is nice is that if this stuff goes away, which happens, maybe it just got restarted for some reason, this other stuff can continue running. And you might even imagine that like this runs somewhere totally else on a different machine even, although that is really rare, it could happen. And also whenever this comes back up, it loads some state off a disk to see what it thinks the state of the world should be. And it kind of compares that with the actual state of the world to load back up into memory, where it left off before it shut down. So it can sort of take control back of whatever's running over here. So that later it can stop it or issue commands to it or whatever Nomad might want to do with running task. That's all great and wonderful and nice and stable, and that's why everybody does it that way. But I didn't do it that way. I cut out all the sort of servery side daemon-y kind of persistent thing outside of Nomad, and I'm just going to run everything in a driver process. So in my case, my task, instead of being run a Docker container or execute a command, my task will be a Go routine within the driver process. That's really convenient for me because with music, you need to coordinate multiple parts of the music together in very precise timing. And Nomad doesn't do that on its own. If you have separate tasks, then Nomad just like tries to get them up and running, and it doesn't really pay any heed to your sensitive ear to try to make something that sounds like music. And if it gets off at all, then it turns quickly into noise. So we need to be really careful about our timing. So I just put it all into Go routines in this driver process so that I can have my nice strict timing. You might see like a problem with this picture, which is that if that stuff goes away, well, the music stops playing, right? Because Ableton is just sitting here listening on this port and nothing's going down it. So if my driver process crashes, our Nomad client restarts, which tends to bring the driver process with it until it launches it back up after a restart, then Ableton will just sit there quietly. But that's totally fine. I'm sure nothing will go wrong, and it'll just work fine all the time. And it's Hack Week. If I was going to do this right and like productionize my MIDI driver for some reason, then I would make a little daemon that ran out here that, again, the driver would just be like a thin client for. And it would be mainly responsible for integrating with Nomad and then have a separate thing, like the previous picture to keep things up and running. But again, it's Hack Week, so screw it, just shove it all into one process. Cool. Well, I'll show you kind of what I'm aiming at, and then we'll walk through how we get there. So our target is to have a job specification that looks a little something like this. And it has, job name, group name, task name. This is a mallet. It'll go clunk, kind of a sound. So that's one part. This all represents one instrument playing. I tell it my driver, which is not as catchy as Maestro, but gets the job done. The song here is just a string that is used as it's basically like a key and a map of clocks. We're only going to have this one song, but this is what allows my driver to synchronize many of these separate jobs. So you give it the song name, and as long as they all have the same song name, then it will line them up on a clock that I get going based on this. Feed it the MIDI file so that it knows what to read to then process and send over the MIDI port. MIDI port here is the name of the virtual MIDI port, which is in OS X, it's got sort of built in this way to create these virtual MIDI ports, and I've got one for each instrument. So that's great. And then bars is how long the MIDI file is. You want to have different length instrument parts, otherwise it will sound quite bland. But I didn't teach it to process this file to try to figure out how long it is. Again, hack week. So I just tell it, hey, this is 1 bar, or it's 2 bars, or it's 4 bars. So only play it as often as makes sense for that. So I'm sitting here looking at this, and I see mallet, 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 and it's just begging to be templated, right? And this is hack week. I haven't really played around with Nomad Pack all that much, at least not making my own. So this was a great opportunity for me to play with that and learn a little something more as a nice little side quest on my main MIDI project. So this is kind of what that looks like. This is the template. I exclude some other files that Nomad Pack needs just for brevity here, but basically I can feed in this one part name now, and it gets fed in and templated as, you might imagine templates do. And as a result, I can run my single instrument much more simply by feeding it just this one nice, unique word, which I can even, alias down to run mallet. So here's kind of how that works. I'm going to hit run mallet. If I've got my audio set up, you should start hearing it now. And over here in Ableton, we've got a mallet, 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 and this is the MIDI information coming through, and this is what Ableton's doing with it. I'll go ahead and stop that. And that'll quiet down. So while we're here, I'll show you kind of how Ableton is set up. I named everything consistently, so this is just the name of the track. This is the port itself, so this maps over to the MIDI port on the machine, which I feed through the job spec, which talks to the machine port on the machine, which gets listened to by Ableton here. And named everything consistently kind of across the board, strings, and so on, just so I can keep things straight in my head. Each one of these is like the actual track. So for strings here, this is the MIDI data. I did sort of my composition here, just because I'm sort of comfortable in here. And then I can export the MIDI clip, which produces the MIDI file. For any of you MIDI folks who are wondering why all these dang ports and not just separate channels on a single port, for one thing, I want to avoid the word channel because that's a Go thing too. I'm kidding. But really, as far as I can tell in the documentation for Ableton, exporting a MIDI clip from Ableton just has this limitation. You can't export a MIDI clip into more than one channel. Each export just has one channel. I could have produced these files differently to avoid that, but hey, it's hack week, screw it. So I've written all my parts, and I've spruced up their sounds and made them sound all neat and interesting. And I exported my MIDI data out to files, so I can just delete these now. And later on, don't catch me cheating, this will not be running. Everything will be driven by Nomad, by my driver plugin. So I think we hop back over here. And we'll look at a little bit of code. Finally, we got here. So this is the interface that we need to implement. It's in the Nomad repo. You can go and have a gander there. There's a bunch of things that you need to implement that are important for Nomad to know. We'll focus mainly on these, start, lesser extent, wait, stop, and destroy. We'll kind of walk through those because that's what mostly you care about, I think, whenever you're writing a driver. Is like, I want to do the thing, and then when it's done, I want to make sure it, gets cleaned up or whatever. So this is the interface that we'll be implementing. Here's my repo of my implementation of it, hacked together in a couple of days. Not apologizing, that's right. Here's the driver template that I use. So I just cloned this thing. Thank you, teammates, for leaving this lying around for me to just like steal and modify to suit my own purposes. It's got to-do comments throughout it, which are quite helpful to keep you sort of on track and to let you know what all sorts of things you might want to change to get your driver plugin set up to do what you want it to do. Thanks to the maintainers of this Go MIDI library, it speaks MIDI, so I don't have to. Super handy to have. There's a bunch of drivers too. In particular, mine, I used port MIDI on my MacBook here, but there's a few different ways to drive that MIDI data. And now we'll go through an IDE and walk through the actual code. So I'm going to stumble a bit through here probably, but just bear with me. This is main. This is the entry point for the driver, and that's where Nomad will go through. And it expects this to have happened to set up all the gRPC listening and so on. In my case, I added a little bit extra up here so that I could run the plugin outside of Nomad to get it functioning how I kind of wanted it to. Without wondering whether I was screwing up on the Nomad side, or even just to run it over and over again really quickly without needing to have Nomad involved the whole time. But mostly what we want is plugin serve, and that expects a particular interface. It expects a plugin factory, which we've got right down here, as you might notice. Interface, this is always a bit of a smell, right? The reason that it's an interface is that you might have, I'll hop over here into serve, and serve takes that a function with that interface. Serve here can take more than one kind of plugin. It can either do a device plugin like NVIDIA or USB. These are devices, or it can do drivers. These are much more common. It's what we'll be making today. It's Docker driver and so on. And exec and such are all driver plugins, and that's what we will be making. So we'll hop back out up to here and go to our factory and to my little new plugin, which, hey, look at that. I did brand that one. How about that? Cool. So new plugin. I make sure for my own sake that I actually am implementing driver plugin here. Then we'll hop down to start task. There's a whole bunch going on that, again, I'm going to kind of glaze over. Apologies if this is what you were really here for, was to learn about fingerprinting and such. It's really interesting stuff. Look into it, but I'm not going to talk about that today. So, start task. The client has asked the server, hey, do you have any work for me to do? The server goes, hey, it looks like you can do this job. You've got what I need from the fingerprinting that we talked about. So here, do this job. Then the client passes this task config thing via gRPC again over to my driver plugin. It's got a bunch of stuff on it that you might find to be relevant, interesting for your driver authoring needs. For example, I could have used an allocation ID if I wanted to put all of my different instruments or tracks or parts as separate tasks, but still all within one group, then I could have excluded that song key and had like each group gets its own clock. But that doesn't look as nice on a demo. It's cool to have separate jobs that have, nice clean names. So mainly for demo reasons, I just kept the song in there instead. But you might imagine that you can do interesting things with these in your drivers. It comes with this convenient little thing to help unpack the task config, which is going to look familiar here. So we've got our song MIDI file and port name. That's pretty cool. We're starting to connect up with our end goal. So that's nice. We get a task handle, and I'll kind of hop in there and you can see what it is for. It's for state between the driver and the client. So, for example, I can tell it, hey, Nomad client, I'm running now, so we're good here, Or I've died, or so on. It also can be used during recovery. There's some state that you can add stuff in here to persist across driver restarts, but we're not going to bother with any of that. We're just going to let it all crash and burn and pick up whenever it starts back up. That's fine. We have a stateless app. Everybody loves stateless apps, right? That's great. Cool. So we got one of those. This thing is Nomad-y stuff again. We'll get a context, a cancelable context, and we'll hang on to this stopper for later so that we can issue our stop command when we get there so we can cancel the context when we get down to stopping the task, which should stop our player and so on. But we're getting a little ahead of ourselves. We'll get a clock, again, based on that song name. So we get a clock, and each task that has the song will get the same clock. I'm doing the global state thing, because again, this is Hackathon. Whatever, man, it's all in one process. Let's go. I'll make a new player that gets the full config, and we'll bump into that later. The player actually plays the MIDI file out to the port. And we'll subscribe the player to the clock so that when the clock ticks, it can let the player know, hey, it's time to play your tune if you feel like it. And then we've got some more Nomad driver state stuff, sort of statefully Nomad-y integration stuff. Again, apologies if this is the meat of what you wanted to be here for. But hey, doesn't that look just tantalizing? You should just go and find out what that does yourself, get your hands in it, Cool. So now we get some work actually going. I get my clock started ticking. You can always be sure whenever I have a long comment like this that I had a nasty bug that was really challenging for me to figure out. I left myself a note. So that's kind of fun. We get the clock ticking, the player playing, and then we start this other thing, which again is for Nomad reasons, basically. We'll set some state on our task handle so that we can let Nomad know what the result of this was, like if it crashed or anything. Cool. So we'll hop into our clock ticking. Remember, we've got one global clock for everything that is in the same song. So we only want that to be ticking once. So this just guards against it ticking more than one time. I got a timeout in case we get a rogue player. We got our good old infinite loop golang select thing with some exit conditions, as you gotta have. And then we have our time ticker that ticks for us. We set it up before during new clock. On each tick, we get a lock of our subs, just in case, we collide here, we want to be careful. So for each player, we send a bit of nothing info, kinda, down it, real lightweight empty struct, just to say, hey, player, time to tick. And if that times out, then we don't want to, stop the whole world and the whole song. So we make sure that we've got a timeout set there too, in case the player isn't actually listening on this channel for whatever reason. I may have encountered time dragons at some point during this process, so you get nice debug messages like trying to send to. But anywho, we'll head back out to our driver here and look at our player, which actually gets our job done. So we pull the port file and bars out of our config. That's all fine and dandy. We ask MIDI, hey, could you please find that port for me? And if you fail, like, let's make some noise about that. Go ahead and wrap up. This is a little construction to only finish the go routine in here after the music is done playing. We don't want to stop partway through the music playing. So this just makes sure that that happens. We set bar to 1, and we'll talk about that in a sec. We've got another, infinite for select with our exit conditions, escape hatch that, you have to imagine I hit a bug there and found some reason to have that. This is the clock has told us to tick, so great. I mentioned bars before. The clock ticks once per bar. That's its sort of granularity. So if we have a track that is more than 1 bar, we don't want to play it on every bar, or it would kind of stack up, right, and play on top of itself. So we just do a little extra work here to only play whenever it's make sure we don't overlap. We only play on the bar that we need to. Do some more logging. We use our MIDI library again to chew on our file and then to play it to our output port. And now we should have music playing. So looking pretty good. Next up is recovery. JK, not doing that. There is no recovery here. Wait task is, Nomad has cause. It's alloc runner, I believe. Don't quote me on that. At any rate, sometimes the Nomad knows that we need to wait on things to complete, so it does that there. I know that whenever I want to stop my task, I want the music to stop playing, as you might imagine. So I get a cancel context here, or a timeout, excuse me. Nomad gives us a timeout, and this can go through the job specification, I think. So we want to respect, right, the timeout. So if it tells us to stop, but only try for so long, we want to respect that. So we give it a context to only wait for that long. But we unsubscribe the player to the clock so that the clock doesn't try to continue sending ticks down it to its channel. We stop the context that we set up in run task, which should cascade down, and player's wait here should catch that and bail out. Then we also want to clean up after ourselves. So in another task, your task might set up, say, like network rules or something. But here I have a piece of shared, state that sort of sits around afterwards. And that's my clock. So I need to make sure that I clean up my clock from memory. Really doing some real heavy lifting, deleting my 1 clock from memory, from global state. All right, well, that was a walk. Let's hop over here. And I will get myself out of the way. And we'll play the demo. Hope you enjoy. Thank you, everyone, for tuning in. I hope you enjoyed the show. I hope you understand Nomad task drivers a little better, and I hope you feel inspired to make your own. It's a lot of fun. It really can be anything. Okay, bye, builders. Bye. Bye now. Bye. Bye.